Okay, this is take two. I've already done this once, but the sound didn't record. And believe me, it was the best stuff I ever said. So I'll start it off the way I did before by saying I don't know how to start these off. So I'm just going to do it. This is George. George here is a robot. Built a while ago. I'm going to show you some really old pictures of George from a long time ago. How long ago? You can see the stamp date on here on his circuit board, 1998. What's the story of George here? Back when I was a newly minted physics professor, trying to impress everybody that I was working with and teaching, I decided a class that I was running at the time, it was for seniors, doing modern physics experiments, measuring the speed of light, Planck's constant, gravitational constant, just doing, highfalutin physics and scientific data keeping and experimentation and writing and all that kind of wonderful stuff. Everything a good science professional should do if they're going to get into experimentalism. And I decided that the students needed to build something technical and not really know much about it and just kind of wing it. So, George. George is a beam robot. It stands for Biological, Electronics, Aesthetics, Mechanics. It was coined to kind of capture the essence of, can we use simple electronic devices, resistors, capacitors, photodetectors, diodes, transistors, things like that, to mimic neural networks and biological responses. And so these things were born. And there were all kinds. There could be ones that could sense light, sense sound, radio frequencies, temperature differences and gradients. And they were just to respond to their environment and interact with it kind of in a very biological way. And got some of these, kits essentially, and we built them and tried to mess with them, figure them out, and a robotics thing was suddenly born. And this is just the first one from a long time ago. So George here has been, it's the only one I still had, or at least I thought. And he's been sitting on my shelf for a long time, and I suddenly looked at George and I went, George, you need some help. Maybe I'll update you. And I also started, trying to find some of the old materials and things that I had for this. And by chance and luck, as I was looking through a file cabinet in a dark recessed corner, I came across the ability to give George a sibling. Apparently I had one of these old kits laying around, and I thought, hey, let's build it. Let's give George some companionship. And it's been sitting in a drawer, forgotten about, for 23 years. Apparently, this is the George is a 1998 edition, and this is a newer revision, newer of 2001. So there's a millennium bug here. So why not build it, put it together? I'll probably, gonna ruin its worth here by opening the new in-box Scarab beetle, Cybug version 1, artificial life form. He's always worked, or at least he had the last time I messed with him. So let's get this adventure on the road. But hey, you want to go along with the journey with me? I think you should, because why not? I think it'll be fun. Plus, I need to fix George, get him working fully. Okay, apparently beam robots were reaction-based behaviors based on the characteristics of biological organisms using just basic electronics to mimic neural networks. So that's a big lift for something that's like this, but it certainly sounds interesting. I guess form follows function. Going back through my old notes on this, apparently there were like themes of the early little electronics to sense their surroundings, you know, bump into things or look for light sources or even fuel themselves. You could actually build a rechargeable base station. It was like a flower, and you could these would sneak up to it and recharge, so you could put rechargeable batteries on it. And they had all kinds of themes. There were sitters, squirmers, sniffers, crawlers, jumpers, rollers. There were all these like fancy terminology, walkers, for these little robots. I don't think I remember any things that were like swimmers that could swim, but I know there were some that could fly and definitely ones that could climb. So let's build it. This little kit came from a place in Canada, because I think this is actually somebody in Canada is the one that coined the term beam robotics. And this came from jcminventures.com. And they're still out there. In fact, they still sell a version of this Scarab Beetle kit. Who knew? But they're still out there doing this little stuff. This the first place I came across beam robotics and how it even entered my consciousness and something that I could use with my students. There was an article in a magazine I had called, or got subscribed to at the time. I don't even know if it's a magazine anymore. It was called Discover. And I can't remember I'm going to have to go look it up. Okay, the guy's name was Mark Tilden. Apparently he's fairly controversial, but if you've ever seen in a toy store one of those Robo-Raptor, Robo-Sapien, Robo-Quad, Robo-Dinosaur robots, that was him. If you start searching for beam robotics online, you end up a lot in the Wayback Machine. I'm beginning to think I'm old. Well, here we go. Let's see if we can't start putting something together here for our good friend George. Hopefully we can. I'm also going to do some refurbishing of George here. Not the best soldering that's happening under here. Even broke out the scope for this. Let's see what happens. Okay, first, 2001. Let's see what's going on in this thing. I'm going to crack it open. Oh my. Here we go. Okay, first, nice instruction manual with all of the pieces and everything that's going on. Even tells you how to do some good soldering. Just the right amount. It'll look like a volcano. Not enough will look flat. Too much, a little blob. I'll probably get a blob most of mine. How to read resistors, parts list, pinout connections, electrolytic capacitor information, and then the actual how to fabricate and build. Cool. Step-by-step instructions. Fabrication and theory. What goes where. I'm allergic to instructions, it would appear. What to connect and where to connect it. What choices to make along the way. How the motor works. How to test the motor. This will work nicely. Let's see what happens here. Ooh, it even has the build the Cybug feeder, which unfortunately I don't have anymore. That was cool. Had one of these back in the day. Don't know whatever happened to it, to be honest. I think one of my students took it. Evolution possibilities. Oh, and the schematic diagram. Probably can't see that very well. And then other things you can do. You can give it a hunger instinct, a predator instinct, and some other kits. I actually found one of these stored away. Maybe I can get it working too. So let's actually start building it. The parts. Here's the circuit board. Nice. Cool beans. Artificial life form, revision C. The earlier one was revision B. So this one is updated slightly. That's cool. and all its connections. A list of parts. Ooh, the glue stick is not dried out. They even gave me an extra wheel. The motors, wire connections, zip tie, and a bag of Good Lord, look at those capacitors. There is nothing so big on this guy. Huh. Those are much larger. Interesting. I actually have some leftover pieces from previous builds of, I guess, Revision B. And let's see, the big ones here are 1,000 microfarads. What are these guys? Doesn't even say. I can't see the... I'll just have to take it out and see. But there's definitely a few differences in pieces here. They're very interesting. Huh. Anyway, I'll keep this just in case. Let's see what those capacitors are. Those are very different. Before it was all packed on a nice little piece of foam, nicely organized and labeled. This time, just in a bag. Okay, what do we got here? This is, yeah, that's the 1,000. Those are very, very different sizes. Huh. I wonder why they went so big. Huh. Of course, these have been sitting in a bag for 20 years. These have been sitting like this for 20 years. I don't see any other vast differences. Some of the other capacitors are just different colors. Although they look exactly the same as the previous generation. Diodes are the diodes. Okay. Photodetectors are the photodetectors, photodiodes. Potentiometers, okay. Everything else is kind of the same. I'm going to be bending leads, so I printed out a 3D lead bender because I'm going to be like professional and everything. I might as well have very specific bent components. Okay, I'm going to work on George here. He needs some love, some finishing work. So I'm just going to throw him under the scope and go over all the solder joints and everything. His wheels are cracked. His antennas are all messed up. Motor isn't really set on there very well for his feet. So I'm just going to go through, kind of give him a little love, see what I can do, put him under the scope. And that is the moment my microphone quit. So, you're getting voiceover, Dr. Joe. I started just trying to re-solder, reconnect, to make sure there were no cold solder joints on George here. I was trying to give him a little life, a little extra, care, trimming. And was going through very carefully, re-soldering all the joints. Everything appeared to work just fine as I did this, and the work was going really well. So at this point, I thought everything was going to be fine and dandy with George. But we'll see, because I did run into trouble a little bit later. So this is just basic circuit board cleanup and making sure all the solder joints are good. I did end up removing the feeler wires for George's antenna because they were really bent up, corroded, oxidized, and messed up. And I'm going to rebuild them, as you're going to see. So here are the wires that were his feelers. And I first had to scuff them up because the oxidation was pretty bad. And then I had to remember that there's these little areas up front that the wires go through to make connections when he bumps into something to trigger parts of the circuit. So that's what I'm pointing out here, showing you how they feed through. And they have to make contact. So that's the plan for that. And I decided to, bling them up a little bit with some shrink tubing and create kind of a more buggy antenna system. I don't know. I was just going for some bling. So here I am wiring the antenna back up, putting them back in, soldering them, adjusting them nicely. And then I also thought his glue stick feet needed updating because his glue stick feet were dried, cracked, and falling off. So I dug up some old Legos to use as wheels for his little motors and use some shrink tubing to make up the size difference and kind of make them grippy. And then pretty much most of the work was probably done at this point. I just had to make sure it worked. I also updated the 9-volt connector because the old one on it had actually broken, and I had never noticed before. It was barely hanging on, so I made sure that was a new one, and it's much more robust than before. Also built him some, I guess, ground feelers to keep him level and on track as he scurries around, and that way you'll see me testing it out right there, and that way he doesn't face up or face down. He's kind of level with the ground. And then it was just a little bit more cleanup and making sure everything was kind of ready to go. And then when I was actually testing him carefully, I ran into a problem. It would appear one of his 5.5 timers was not functioning. So when I powered him up here, I noticed one of his sides, one of his brains, essentially, he's kind of right-brained and left-brained, wasn't working. So I had to really carefully figure out which chip it was. And in this video part here, it's the actual upper right one. And after I placed it, he started behaving correctly. And here you see me testing him out after that replacement, after that fix was tracked down. Either that 555 timer wasn't working when I started working, or as I worked, I decided to give up the ghost. But after replacing it, it was fine. And now it was time to give George a sibling. And since I'd already picked one as George long time ago, I figured why not Georgina? And here's the building of Georgina. Again, my microphone was out at this point and I didn't know it, but here I was very carefully explaining some of the differences I'd noted between version B and version C that I'm working on here, with the 3-year difference. It appears that a couple of the capacitor values have changed. Some of the ones up front on George were 100 microfarads. On Georgina, they're 47 microfarads. And a couple other things changed here and there, but they really weren't all that different. The photo detectors were slightly different, but they spec'd the same. So here's the chips that we have. And, again, they hadn't changed. They were still the same chips that were plugged in. Same transistors all around. So it was really just a couple capacitor differences, and the photo detectors were a little bit different. But here I am very carefully showing off the values and differences from blue film capacitors in the original yellow, and that one big capacitor. Those changed. They not in value, but in size, and you can definitely see the differences between them. The photo or light sensing detectors were very similar, just a little bit differences in color and size. Maybe just differences in age, really. Now it was time to get serious. So here I am, just populating the circuit board for Georgina here, putting in the resistors, the capacitors, the various chips, and all kinds of things, and very carefully going through and soldering. I was talking this whole time, giving, neat little stories, and I can't remember them now because this was a while ago. I'm sure they were fantastic stories and, could change people's lives, but it didn't get recorded. So it'll just go off into the ether of never being heard. So here comes the music montage of me A-teaming my way through the build. Oh, I showed my age there with the A-team reference. They were always doing a musical montage during the show where Suddenly they could build an aircraft carrier and all kinds of things and solve and save the day. So basically, I love it when a plan comes together. George had photodetectors that were kind of short and installed so they kind of look straight up. I decided on Georgina to angle them a little bit and create some maneuverability with the photodetectors so I could aim them in various ways if I wanted to. So I decided to add a little shrink tubing to the leads to help protect them, and then set it up so again they could be angled and I could give Georgina some better visual acuity as I was planning on setting her up, I guess, to see and sense out light. So a photophile in a sense. Here's Georgina with most of everything populated on the board. All the chips, potentiometers, resistors, photodetectors, LEDs, capacitors, 555 timers, transistors. I think I said transistors. But here is everything on the board. There's still some work to do. I have to build the motors and make the attachments there and add them in. And that's what you're going to see now. So I had to create some wire leads and figure out a way to attach them. The instructions called for using some wire and soldering them to the case of the actual motors, but the solder doesn't want to stick to it. So what I ended up doing is scuffing up the motor casings with some sandpaper to create some rough terrain for the solder to grip onto. And you might see that in this, but I can't remember if I recorded it or not. And now is to fashion Georgina some nice feelers and connections. So you'll see a little empty spot there where a little bit of brass wire goes to make those connections into the circuit. And that's what I'm putting together here. And then you have to figure out how to bend the wires, get them through there, and make the actual feelers. So that's what I'm doing now, trying to create nice little antennae as a way to interact with the environment and trigger various parts in the circuit. So you're going to see that. And again, I'm going to use some shrink tubing and kind of make them purty. comes the moment I realized I wasn't recording any audio. Dang it. Microphone. Yay, it's working now. This is going to be my switch. At least for now. And the switch goes right here. Where those little two pets. Quick power test. That would be a power test. It should be the end of the soldering. I say that now. Oh yeah, no, there will be more. I gotta make the braces. Gotta do the feet. And my antennas. Make good contact back and forth. There and there. It's looking kind of spiffy. Decided the battery needed to adhere to the circuit board a little better rather than rattling around. So I just have a little bit of magnetic material, some magnets with some double-sided tape that I can stick down the magnet with. So here's George and Georgina sitting on my desk moments ago, slowly trying to find their way to the light source. So I think builds have been fairly successful, and George and Georgina have made it to the modern day time of now. I'm kind of curious if any of these other things out there still exist, so I'm going to dig through all my stuff and see if I can't find some more to maybe update and look at. Thanks for watching. Enjoy!